Good evening, ladies and gentlemen. It's good evening here in Los Angeles, California. It's February 1, 2022. My discussion tonight, I will be having a topic on something like related to energy or related to electronics, something like that. I will be having a discussion on energy meter. This is actually a portable energy meter. Energy meter is a meter that what you call this register our energy, our power consumption, what we are paying to the utility companies. Okay. I will try to bring out the characteristic of this energy meter. It says here kilowatt. Oh, it's synonymous to a kilowatt, something like that. Because kilowatt is actually the power consumption of our houses. Okay. The things to be measured by this energy meter, I just wrote it here. Number one, it could measure the frequency coming from our power lines. Here in the USA, the power line frequency is 60 Hertz. So I got a load a while ago. Later on, I will try to place it, but for the meantime, I will try to read it, to read what comes out after plugging the load, a small electric pan. Right? The volt ampere of the electric pan coming out from here, volt ampere, is 15.4. The watts coming out from here by using this load electric fan is 12.3. The amperage, the current consumption is 0.13 amperes. That's AC current, alternating current. The volts coming out from here, of course, the voltage coming from the utility line here in the USA, they say it's 120 volts, but it's not actually 120 volts. It could be higher a little bit than 120, lower than 120. What it registered here is actually 117 volts. And the power factor is 0.79. Power factor is in electronic circuit or in electrical engineering calculation, power factor is the ratio of the true power over apparent power. If the power factor is 1, your load is actually very efficient. There's no wastage. In here, the power factor coming out from the load electric pan, okay, is 0.79. So meaning it seems that the efficiency is only 79%. We got a wastage. It's not really wastage because this electric pan here, it's not a pure resistor load. It's a motor load. It got a winding and a resistor. If the load is a pure resistor, the power factor will be 1. But if the load is a combination of something like a motor, we cannot do anything about it. Motors got some windings, so it's not a pure resistor. So actually the power factor is less than 1. Okay. And here I've tried to verify the value of watts because I've been teaching electrical engineering for not so long, but I know a little bit. Not little bit, I know something. I could compute, I could verify that the watts here that's being registered here is correct or not. Actually, watts is the value of the volt ampere times the power factor. I tried to multiply it. Okay, later on I will show you. 15.4 times 0.79 coming out from this load. What comes out is 12.12. Okay, when we place this load, plug into this, what comes out is 12.3. So actually, we could verify the reading if it is correct or not. Mathematically, we could verify it. Okay, as an engineer, I could verify if the reading coming out from here is correct or not. Okay. For the volts is actually voltage, right? Ampere is current. So, in general, volt ampere is the product of voltage and current. Okay. In here, the voltage registered is 117 times the current 0.13. What comes out for the volt ampere is 15.21 using my calculation. But by using the meter from this, it says 15.4, more or less, right? Theoretical value from the actual value is a little bit, there's a little bit discrepancy, but at least we could say that the reading is very near 100% accurate. Okay. And power factor also, I could verify if the power factor reading coming from this load is correct or not. That's being registered here. Okay. Power factor, by definition, as an electrical engineer, power factor is the ratio of watts over volt ampere. Kilowatt over kVA is power factor. The watts coming is 12.3. The volt ampere is 15.4. Okay. If we divide these two here, it comes out 0.798. And from the reading of this, it says that the power factor is 0.79. So our calculation plus the reading in here was almost 100% correct. Okay? Okay. To determine the energy consumption of any load in our house, is actually we must have to use this, specifically like the entertainment center. If you got a convenience outlet that's dedicated for the entertainment center, for you guys to know the energy consumption, you must plug in here, and the consumption for the entertainment center will come out here. Any load in your house, you could do that. So actually, if I will plug in this one, okay, this electric fan is actually DC. This is a step-down transformer. The output of this is DC, but the voltage input is actually alternating. That's the one coming from Southern California, Edison. Okay. Then I will try to plug in this on a live convenience outlet coming from Edison. Okay. Then try to switch on. Okay. The electric fan is on. Okay. If I will try to toggle the button here, it will come out that frequency 60 Hz. Okay, 60 Hz. The volt ampere will be 15.4 if you try to see it. Okay. The watts that will be coming out is 12.3. Okay. The ampere, the current consumption. Okay. It will come out 0.13 if you try to toggle the button over here. I could not show you, it was horizontally placed, you know. And the volts is actually 117, and the power factor is 0.79. So any load in which you want the energy consumption to be known, you just plug it here on the portable energy meter. Actually, you can buy this online. Okay. Any load that you want the volt ampere, watts, and ampere, and the power factor to be known, just plug it here and you could read it. Then, if you are an electrical engineer, you know the formula on how to take these values. You could verify if the readings coming out from the meter was correct or not. Okay? So, as an engineer, if you do this one, you are at the so-called advantage. Because actually, for us engineers, we just don't believe the readings here. For us to verify the correctness of this, we could use our mathematical formulas to verify if the reading coming from the meter is correct or not. Okay? Oh, this is just a plain knowledge for the simple layman, you know. If you don't know nothing about electricity, this is for you guys, for you to understand it. Okay? So actually, this energy meter was a combination of so many meters, because I got the multimeter here, and if I will tap this multimeter on the power on the convenience outlet, actually if I will set it to frequency, I could measure the frequency, right, by using this. But by using this energy meter, it could actually measure the frequency already. So there's no need for you to use this one. But on the field, okay, if you don't have the energy meter, you bring this, you could still measure the frequency. Okay, by using this, you could measure the current, the voltage, frequency, the three ones. But the only one thing that could not be measured by this meter here is the power factor. But for this energy meter, it could measure power factor. Power factor is a relation in which you will know if the efficiency of your house wirings or something, the motor loads or other loads inside the house is good or bad. If your frequency is less than 1, it's not a perfect load. It's almost like that if you got a load of a motor loads like air conditioners, right? Washing machines. Whether we like it or not, the frequency will be less than 1. It's the average, I think, is around 80%. Because motor loads got a power consumption that is, we call it apparent power and the true power. Okay, if the load is just a pure heater, that's a resistive load. The power factor is 1. That's very efficient, but it's a waste of current. It's too much, right? So that's the importance of this energy meter. Okay, I will shut it off. Okay. Okay, I will remove the load. So for you to see, guys, this is an energy meter. Okay, it could measure frequency. It could measure volt ampere. Volt ampere, in terms of kVA, that's why maybe you've been hearing that the power rating of the transformers on the post is in terms of kVA. That's actually apparent power, right? If it's VA, it's just only small. But if there's a connotation key over here, that's a 1000 volt ampere. That's very big already. That's why power plants are rated MVA, million volt amperes. They are giving thousands of currents to the customers, right? The watts, it's the same. Okay, ampere. That's why engineers used to design transmission lines for them to know the current capacity of the transmission lines for it not to get burned, right? Volts, it's a problem of the designing engineers. Power factor, it's the ratio of true watts and volt ampere. So that's the importance of this energy meter. Okay, this is just an information for those who don't know nothing about energy meter. Okay, that's it for you guys. If you've got any problem on this, try to message me. Okay, I think this is just more than good enough for tonight. At least we now know what is an energy meter. It measures frequency, it measures apparent power, it measures true power, it measures current, it measures voltage, and it measures power factor. 1, 2, 3, 4, 5, 6. It could measure 6 quantities. Okay, that's being measured by some of the multimeters on the market or by the one used by electronic technicians. That's it, guys. Good evening, Los Angeles. This is Know-How on Electronics. Thank you.